Hello students. Now in this video I will start with the concept of derivatives. Now the overall concept, its geometric meaning and real life explanations have been already done in the theory classes. So I won't repeat that again. Now only in this video I will only cover up those topics or those things which are important from the examination point of view. So this you can just look at this as only a revision. Okay. So now about the derivatives, I have already explained that it is a kind of rate of change. Okay, the change in any variable. Now for example, if you see about the formula of speed, which is distance upon time, that is what, as the time changes the distance also changes. Okay, if it is any body or anything is moving at the constant speed, or let's say with any speed, the distance covered increases with the time. Okay, so you can treat this as a function of this distance as a function of time, and it is dependent of time. Okay, so in such cases where we say the change in that distance per a change in time, that can be called as a, or that can be referred to as an example of derivatives. So now mathematically we have certain formulas. Firstly, we refer to these derivatives by this d by dx. This is a symbol of derivatives. Okay, for example, if y is a function, y of x, as we say, a function of x, that is y is dependent on x, then the derivative of y with respect to x is d by dx of y. Okay, so d by dx is a symbol, or even we refer to this as y dash. It is understood that the dash means it is a derivative of y. Now I'll give a certain formulas. For example, one formula which we have even covered in our IT was d by dx of x raised to n is given by n into x raised to n minus 1. Now what does this means is that, now if any function is there, okay, f of x is, let's say, x square, our most simpler one function. Now if you compare this x raised square with this formula x raised to n, that means what, n is my 2 in this case. Okay, now if I want to find the derivative of this d by dx of x square, okay, then what will be the formula, n x raised to n minus 1. But here what is my n is my 2. Okay, so what I will write, d by dx of x square is 2 into x raised to 2 minus 1. That is what, 2 into x raised to 1, that is x. So formula for d by dx of x square is 2x. Okay, if you see again another example, f of x is equals to, let's say, x cube. Now here if you compare this x cube with x raised to n, I can say n is 3 here. So d by dx of x cube will be given by n x raised to n minus 1. So in place of n, I have 3, then x raised to the power n minus 1. In place of n, I have 3, so 3 minus 1. So 3x square. This is what the formula of d by dx x cube. Similarly, if you see, f of x is equals to x raised to 7. Now, x raised to 7, what it will have? D by dx of x raised to 7 will be given by Now here value of n is 7. So 7 into x raised to 7 minus 1. That is 7 x raised to 6. This is the formula. Okay. So this is how we apply this d by dx of x raised to n is equals to n x raised to n minus 1 formula. Okay, so one of these is very important. You can get a question in exam regarding finding the derivative of or differentiate this. Okay, basically whatever we have found these values, okay, for this x square we have found this value as 2x, for this x cube we have found this value as 3x square, or for this x raised to 7 we have found this value as 7 into x raised to 6. They are called as the derivatives of this function. Okay, so 2x is a derivative of x square, and this entire process of finding the derivative is called as differentiation. Okay, I have already explained the literal meaning of this, okay, or everyday life meaning of this. Now this is one of the formula and this is how we deal with this. Now another most important formula we have in derivatives is, now this one was our algebraic function. Now going back to the next kind of function, that is trigonometric functions. Now d by dx of sine of x. Now the formula is given by d by dx of sine of x is cos of x, and d by dx of cos of x is minus sine of x. These are the two formulas which you need to use. Okay, we will see how the problems based on this can come. Now before that, now we can see for if any function is a constant. For example, f of x is some constant, then d by dx of any constant is 0, directly a 0. Okay, so for example, if you see d by dx of 3, 3 is a constant, it is a 0. D by dx of 7, it is a 0. D by dx of minus 2, a 0. D by dx of root 2, a 0. D by dx of pi, a 0. D by dx of 100 or 1000 is a 0. Okay, so for any constant if you see, it is a 0. But if you have a function of this kind, f of x is equals to 2 into a function of x, for example 2x, let's say this 2x, then what you will do is you will take this 2 outside. That is what d by dx of 2x will be 2 times 2 will come out into the d by dx of that x. Okay, so this is how you deal with these functions. If 2 or any constant is coming individually without any x term, then the derivative of that is directly 0. But if the constant is coming with any other function of x, then the derivative, for finding the derivative of that, you take out that constant outside and you differentiate the remaining function. This is how we deal with this. Now finding the answer for this, now d by dx of x, that is what x raised to 1, that is what, now if we apply the previous formula, I have n is equals to 1 here. So d by dx of x gives me 1 into x raised to 1 minus 1. That is what? 1 into x raised to 0. And you know that any term raised to 0 is 1. Therefore 1 into 1. Therefore it gives me 1. So derivative of x with respect to x is 1. So what it gets is 2 into 1, that is 2. So this becomes the derivative of 2x. Now let's take an example of f of x is equals to 2x raised to 3, 2x cube. Now as I said again, d by dx of 2x cube. 2 is coming outside, it is a constant, but it is along with a function of x, that's why 2 will come outside. What remains is d by dx of x cube. And we have seen that the d by dx of x cube will be 2 into the derivative of this will be, now the value of n is equals to 3. So I will have 3 into x raised to 3 minus 1. So that comes out to be 2. 2 into 3 will give me 6. X raised to 3 minus 1, that is 2. 6x square. So this is the derivative of 2x cube. Okay. So this is how the things change. Now I'll take one more example. F of x is equals to 2. Why 2 again? Let's take 4 sine x. Now I can do this as d by dx of 4 sine x. Now yes, 4 is a constant, but it has come along with the function of x. So what I will do is I will take that 4 outside and I will find d by dx of sine of x. And we know what is d by dx of sine of x. We have seen just now d by dx of sine of x is cos of x. Okay. So I will write here 4 times cos of x. Okay. So this is how we make use of these formulas. Now, these were all the individual examples. If you get an example of this kind, f of x plus g of x, that is what? If you get any example or any function of the kind x cube plus x square, what you will do? Now, in this case, what happens is if you want to find the derivative of x cube plus x square, the derivative is distributive. That is what? It gets distributed over the addition. So, what you will get is d by dx of x cube plus d by dx of x square. Okay, so what you will get is here 3x square plus the answer for this part is 2x. So this becomes your final answer. So that is what you have to differentiate it separately. Now let's take an example of d by dx of x raised to 3 plus 2 sine x plus 4. Now, what will happen here is d by dx of x cube plus d by dx of 2 sine x plus d by dx of 4. Now, d by dx of x cube will give me 3x square plus, how this will change? 2 is a constant but it has come with a function, therefore 2 will come outside and what will remain is d by dx of sine of x plus d4 by dx. That is what? It is the derivative of a constant, that means it is a 0. So what remains is 3x square plus 2 into derivative of sine x, and we have seen that derivative of sine x is cos of x. So this is the final answer. Okay. Similarly, if we want to find d by dx of 1 by x square minus 2. Now this is also a function. Now how to write this as d by dx of 1 by x square, and again similarly minus sign will come out, d by dx of 2. Now this 1 upon x square, we know that 1 upon x square can be written as d by dx of x raised to minus 2. We have always seen this 1 upon x raised to m. When it goes in the numerator, it becomes x raised to minus m. So similarly, this x 1 upon x square becomes x raised to minus 2. Okay, minus, now this d by dx of 2, d by dx of 2 is 0 since it's a constant. Okay, now what we will do to this x raised to minus 2? Now again this is of the form x raised to n. So but what is my n? N is equals to minus 2. So what I will do here, the formula for this becomes minus 2 x raised to minus 2 minus 1, x raised to n minus 1, no? So minus 2 minus 1. So how it changes to minus 2 into x raised to minus 2 minus 1 is minus 3. So that is minus 2, and when you take it in the denominator it becomes x cube. Okay, so this is how we deal with this. So now even minus 2 into x raised to minus 3, even if you write or even if you stop at this step, it is totally fine, or even if you simplify, that is also totally fine. Okay, so this is how we solve with such problems. Now this was about addition of two functions, this is about subtraction. Now looking at the multiplication, so I can say derivatives of multiple functions. So now what we do is, if there is two functions, u of x, u is a function, into v of x, v is also a function, then the derivative of this u into v is given by u as it is into derivative of v, d by dx of v of x, plus v of x as it is into the derivative of u of x. You might have studied this already. Okay, so now for example, I'll take an example of d by dx of x into sine x. Now what is u and what is v? My x is my u and my sine of x is my v. So u is equals to sine x, v is equals, sorry, u is equals to my x, v is equals to my sine x. What you will do, you can choose it randomly. Okay, you can write as sine of x and v as x, that is also totally fine. Okay, so how you I will start this is, what is the first step? U of x, writing it as u of x. What is u of x? X itself. Now what remains? D by dx of v of x. V of x is what? Sine of x, plus what has to come here? V of x. V of x is as it is, that is sine of x, into the derivative of u of x. U of x is x. Now if you simplify, this will come as x into d by dx of sine x is cos of x, plus sine of x into d by dx of x, and we have seen that d by dx of x is 1. So this is my final answer, x cos x plus sine x. This is the required derivative of this. Okay, so now what I will do is, if I take an example of, if I want to find derivative of x square plus cos of x plus 3x cube, what I will do is 3x cube, let's increase this further, plus x cos x. What I will get is, I will have to write, this can go to any number of terms. Okay, I will start with d by dx of x square plus d by dx of cos x plus d by dx of 3x cube plus d by dx of x into cos of x. Now d by dx of x square is 2 into x raised to 2 minus 1, that is 1. Now d by dx of cos x, we have seen it is minus sine of x. We have taken this from the formula. Then derivative of this is 3 will come out, and what remains is the derivative of x cube plus, now using here u into v, I'll take this as u, I will take this as v. So what will happen? U of x as it is, we have this formula, no, u of x, derivative of cos of x here, in place of u of x I'll just write x plus cos of x as it is into the derivative of x. Okay, so now if I simplify, the first term is 2 into x minus sine of x plus, now the derivative of this 3 as it is, and the derivative of this is 3x square, 3x square plus x as it is, derivative of cos of x is minus sine x plus cos of x, and the derivative of x with respect to x is 1. So if we just simplify, it comes out to be 2x minus sine x plus 9x square minus x into sine of x plus cos of x. Okay, so this is how we solve, or this is how we use the derivatives. Now one more formula which will be of your help is d by dx of e raised to x. Now the derivative of e raised to x, exponential function, is e raised to x itself. Nothing changes. Okay, as it is you will write. So derivative of, let's say, 2 e raised to x is of the form 2, as it is a constant, it will come out d by dx of e raised to x. And we know what is the e raised to x? E raised to x itself. So 2 e raised to x is the answer. So here also again the derivative does not change. If I want to start with d by dx of x into e raised to x. Now again x is a function of x, e raised to x is also a function of x. So it's a multiple. So again u into v I will have to use. And if we use u into v formula, I will have what? U, that is x, into derivative d by dx of v, that is e raised to x, plus e raised to x to d by dx of x, and it will give me what? X into derivative of e raised to x is e raised to x itself plus e raised to x as it is, and derivative of x with respect to x is 1. So if we just simplify, e raised to x is x plus 1. If I take e raised to x common, or even if you stop at this point, it is totally fine. Okay. So this is all you need to know about the derivatives. Now, once the derivatives have been known, the next thing you need to know, or next thing which comes hand in hand with derivatives, is a process or called as integration. That is what integration is, a process. So an process exactly opposite to the differentiation. And the way you find the derivatives, here you are going to find integrals. Okay, so if there is any function f of x, there exists a integral of that. It is denoted by integral f of x, and with respect to x, therefore dx. Okay, so now if you see, any function of the kind, let's say f of x is of the form x raised to n, then you have a formula: integral of x raised to n dx is given by x raised to n plus 1 upon n plus 1 plus c, where c is constant of integration. I'll explain you why I said this is a process exactly opposite to derivatives. Derivatives or differentiation is differentiating or looking at a smaller points. Integration is something similar to the summation, or I can say addition. Okay, so we together we integrate the things, that's why it is integration. Now I'll just give an example why it makes exactly opposite, why both the things are opposite. So basically differentiation is going to a smaller parts, but integration is summing up together everything together, so it's literally also opposite, and with the formulas also you can see they are totally opposite. Okay, for example, now if you see, if there is a function f of x is equals to 3, or I'll say x square. Okay, x square plus 2, f of x is equal to x square plus 2. Then if you see, if you differentiate this, d by dx of x square plus 2 will give me what? D by dx of x square plus d by dx of 2. That is what? 2x plus the derivative of 2 is 0. So final answer is 2x. Now what I will do is I will just find the integral of this 2x. So for example, if I take example f of x is equals to 2x, what will happen if I want to find the integral? Now see, this is a symbol. This sign integral like a small snake and a dx further. And here you will be writing whatever you want. So that is what f of x now. Okay, that is what integral of integral dx, and in between this 2x. Okay, so this gives me, if we see further, see here also again if there is any constant here that will come out. Is similar to the derivatives, any constant if present it will come out. So similarly 2 is a constant, 2 is coming out, what remains inside is x dx. And if you see it is x raised to 1, so here if n is my 1. Okay, so if I apply the formula x raised to n plus 1, so 2 as it is, and x raised to 1 plus 1 upon it is n plus 1, that is again 1 plus 1 plus a constant c. So if you see this is of this one, 2 into x square by 2 plus 2 into c. That is, if you cancel out this 2 and this 2, you get x square plus some constant. See, c is a constant, therefore 2c is also a constant. This is basically some constant. So if you see here, the original function, you have got what the function you had started with, x square plus 2. You had started with x square plus 2. You got here, when you found the integral of this, you got again the same function, kind of same function, x square plus some constant. Okay, so that's why we say that it is the opposite of the derivatives. Okay, so similarly if we see, we have the formula d by dx of sine of x is equals to cos of x. So now it is exactly the opposite. Okay, integral of cos of x, now this side, now integral of cos of x dx is sine of x. Okay, and we one more, we have d by dx of cos of x is equals to minus sine of x. So what we have here is integral of minus sine of x dx. Sorry, yeah, here integral of cos of x dx is equal to sine of x plus c. We are not going to forget this plus c. Okay, minus sine. So now d by dx of cos of x is equals to minus sine of x. That's why we have integral of minus sine of x dx is equals to cos of x plus c. Now what will happen here? This is minus sign, I can just take it outside. Minus is a constant, no, kind of constant. So minus sine of x dx is equals to cos of x plus c. That is integral of sine of x dx is equals to minus cos of x minus c. Okay, so this is the formula we have. Integral of cos of x dx, integral of cos of x dx is equals to sine of x plus c, and integral of sine of x dx is equals to minus cos of x plus c. Now whenever it is about plus c, actually just now we saw it was coming minus cos x minus c. But this sign of that does not matter whether you write c or you write plus c or you write minus c or you write 2c or plus 2c or minus 2c. It is not going to affect our answer. It is just a constant. So you are subtracting that constant, you are adding that constant, and what constant you are adding, 2c, 3c, 100c, 1000c, it is not going to affect. It's just a c for me. Okay, so it is not going to affect anything. Now I'll just tell you what is the significance of that. Now see, if you take any example, okay, if you go to see a derivative of x square plus 2, you will get it as d by dx of x square plus d by dx of 2, that is 2x plus 0, therefore 2x. If you take d by dx of x square plus 3, it will be again d by dx of x square plus d by dx of 3, that is 2x. So now if you, as I said, the integral is opposite of the derivative, so from this you can just conclude that integral of 2x dx is equals to x square plus 2. From here, if you say, as I said, integral is the exact opposite of derivatives, you can say integral of 2x dx is equals to x square plus 3. If we take one more example, d by dx of x square plus 1000, what it will be, d by dx of x square plus d by dx of 1000, and that comes out to be 2x plus 0 again, that is 2x. So if I use the concept that derivatives are opposite to the integrals, what I will get, integral of 2x dx is equals to x square plus 1000. So basically you will get integral of 2x dx is equals to x square plus something, and that something is varying every time. Okay, so there can be anything, that something can be 2, 4, 5, 6, 152, anything. Okay, so just to represent that number, that there is some constant, we write it as c. So only if 2x, integral of 2x dx is given, you are not going to predict what can be there. 1000 will be there, or there will be these 3 or 2, we don't know that. Okay, so just to say that there is something and we don't know what it is, we just write it as plus c. Okay, that's why this concept of plus c has come into picture. Similarly, even if you see here, integral of cos x dx. See, now the if you want to see the derivative of sorry, derivative d by dx of sin x plus 7, it will be what? D by dx of sin x plus d by dx of 7. It is what? Cos of x plus 0. So from this we have integral of cos of x dx is equals to sin of x plus 7. If this was sin of x plus 3, I would have still got this as cos of x only. Okay, so it's again a issue that what that number should be. But yes, to just represent that there is something but we don't know what it is, we just write it as sin of x plus c. Okay, so that's why it is plus c has come into picture. Okay, so don't forget to add that plus c at the final answer whenever you are finding the integral. Okay, now similarly we have d by dx of e raised to x, e raised to x as e raised to x itself. So that's why again what it will be, the integral of e raised to x dx is e raised to x itself, but with a constant plus c. So that is the only difference. So you have to keep this in mind whenever there is integration, that plus c will come there. Okay, so this is what's all about the integration. And yes, again, if you have something like this, integral of x square plus sine of x dx, it's again same. Okay, you have to integrate it separately, x square dx, same like the derivatives, you are just splitting it. Okay, integral of sine of x dx. Now, integral of x square we have seen, x raised to n. N is what? N is now 2 in this case. So n plus 1 will be 2 plus 1 divided by 2 plus 1 plus there is a constant c plus, if you see this integral of sine of x is also cos of x plus some constant c. Okay, so we are just writing, we will just combine this c and this c together and we will write it as x raised to 2 plus 1 is x cube upon 3 plus cos of x, and just add here a plus c. There is actually no need to write this at every step. There is no need of writing that plus c after each and every integral. Once in the final answer, if you write this as plus c, it is not going, it is correct. Okay, so it is enough if you write it only at the end. So there is no need. Even if you write it in between, it is not wrong, but there is no need also of writing that c each time. Okay, and even in this place, this c plus this c, if you write this as adding this as 2c, it then also it is not wrong. Okay, so you can write it anyways, just make sure that you are writing a c there. Okay, now this is all about the integrals.